In this video, we're going to have a look at how we can find the area of not just a right triangle, but any triangle. So let's consider our first example. We've got a non-right triangle that has two sides, 4.5 metres and 6 metres, with an included angle of 63 degrees between those two sides. Now, if I want to find the area of this triangle, I have to make sure that I've got a base and a perpendicular height, because my formula for the area of a triangle is half times the base times the perpendicular height. So I could use 6 as the base, and I could put in a perpendicular height, capital H, 90 degrees to the base. So before I find the area, I must find that height. Luckily, I can focus on just the left side of this triangle. I've got a smaller right triangle where I've got a known angle, and if I look from that angle, I want to find the opposite side given a hypotenuse. So I could say the sine of 63 degrees is opposite H over hypotenuse 4.5. And the height would just be 4.5 times the sine of 63. Now I could work that out but to about 4.01, but I'm just going to leave it as that at the moment. All I then have to do is substitute this into my equation. So the area is half times the base, which is 6, times 4.5 times the sine of 63. And then I could work out the area is about 12.03 square metres. What I'm concerned about here is that every triangle that's not a right triangle, I'm going to have to try and identify a base and pop in a perpendicular height, find that height, and then go ahead and find my area. But what I'm noticing here is I've used the 3 bits of information given to me: the side, the angle in between, and the other side that encompasses that angle. And I've used exactly those 3 pieces of information to find the area of this triangle. So I'm hoping that there's a more simplified way that I can incorporate finding the height and finding the area in one go. So let's take a look at the generalized triangle below, triangle ABC, and see if we can come up with a general formula. So I've got side little a. I'm going to assume that's my base. I've got another side B and the angle in between C. From my base, I can drop down a perpendicular height, and I can find that height first by looking from the known angle C. So if we go through that same process, the sine of C is equal to H over side B that we know, or the height is side B times the sine of angle C. What I would then do is substitute that into my formula for the area. Half times the base times, instead of height, I'm going to replace putting a H there and putting in this expression that we've just found for the perpendicular height. Whoops, I've just realised that I've written an A instead of a B. So let's pop that out of the way. So let's go back again. The area is half times the base, which is my A representation, times the height. So the height is going to be represented by B times the sine of C. And what we've done is come up with a generalized formula to find the area of any triangle. To find the area of any triangle, I must know 2 sides and the angle that is in between those 2 sides. So the 2 sides and what we call the included angle. Or we can remind ourselves that we could use the phrase SAS, side, angle, side. The angle must be between the 2 sides. And this formula works for any triangle where we have that information. So let's take a look at 2 questions. I'm going to get you started on the first one. So for triangle PQR, side Q is worth 12, side R is worth 5 centimetres, and angle QPR is 108. Determine the area of this triangle. The first thing we need to do is have a diagram so we can visually understand what this looks like. One thing that's sticking out to me is that angle QPR is 108 degrees. So I'm going to draw an angle that's about 108 degrees. That angle is at vertex P, so I've got QPR. There's our triangle. So side little r, which is opposite vertex R, is 5 centimetres, and side Q, which is opposite vertex Q, is 12 centimetres. Okay. What we can identify here is I've got two sides and the included angle. So I have side angle side, and I can go ahead and determine the area. So a reminder that the area of any triangle is half times a side times the other side times the sine of the angle in between. So go ahead and calculate the area of this triangle and then try question 2. Using the area rule and the fact that we know the area to work backwards and find the unknown angle.